Hello everyone and welcome to the next video. In this video, we will primarily study alligations. But before studying alligations, we need to understand the concept of weighted average. So what is weighted average? When we have two or more groups whose individual averages are known, then to find the combined average of all the elements of all the groups, we use the concept of weighted average. Thus, if we have k groups with averages A1, A2, A3 and so on till Ak, which have N1, N2, N3 and so on till Nk elements respectively, the weighted average is given by the formula AW is equal to N1A1 plus N2A2 plus N3A3 and so on till NkAk divided by N1 plus N2 plus N3 and so on till Nk. So let's take an example to understand this better. A school has 5 classes with 10, 15, 20, 25 and 30 students respectively. The pass percentage of these classes are 50%, 20%, 75%, 60% and 40% respectively. Find the pass percentage of the entire school. In this case, to find the average of the entire school, we cannot just simply find the average of 50, 20, 75, 60 and 40. Why not? Because each class has different number of students or different weights. So we will use the concept of weighted average here. Using our concept of weighted average, the pass percentage of the entire school is given as AW is equal to 10 into 50 plus 15 into 20 plus 20 into 75 plus 25 into 60 plus 30 into 40 divided by 10 plus 15 plus 20 plus 25 plus 30. On solving this, you will get the answer as 50%. Now the concept of weighted average also leads us to a very important concept of alligations. Let's understand alligations first, then we will do some numericals. In our concept of weighted average, say we have only two groups, the first with an average of A1 consisting of N1 elements and the second with an average of A2 consisting of N2 elements. Then the average AW is equal to N1A1 plus N2A2 divided by N1 plus N2. By cross multiplication, we get AW into N1 plus N2 is equal to N1A1 plus N2A2. Now bringing all the elements of N1 on one side, we get N1 into AW minus A1 is equal to N2 into A2 minus AW. So N1 by N2 is equal to A2 minus AW upon AW minus A1. So basically we have two formulas in alligation. First one is AW is equal to N1A1 plus N2A2 upon N1 plus N2 and N1 by N2 is equal to A2 minus AW upon AW minus A1. Now it depends on the question which formula you should use to save calculation time. Let's do some questions now and it will become more clear. I am going to cover all the different varieties of questions that are generally asked in the exam. You should observe all the different ways in which alligation questions are disguised. This is because one of the toughest thing to do in alligation question is to actually realize that it is a question on alligation, or to realize that you can solve that question using alligations. For example, you may get a question on time, speed or distance or profit and loss, and you may not realize that by using the concept of alligations, you can save a lot of time in solving that questions. So the most important thing to do in alligation questions is to actually realize that you can solve that question using alligations. So let's do the first question now. 10 pieces of bad quality oranges priced at ₹6 per piece is mixed with 5 pieces of good quality oranges priced at ₹14 per piece. Find the average cost of this mixture. Now this is a very straightforward question. We need to find the average price. So obviously we are going to use formula 1. Now N1, which denotes quantity, is 10 here, A1 is 6, N2 is 5, and A2 is 14. And we need to find AW. So AW obviously is 10 into 6 plus 5 into 14 upon 10 plus 5, which is 130 by 15, that is rupees 8.67 per piece. Let's move on to the next example. On combining two classes of students having an average marks of 30 and 40 respectively, the resultant group has an average score of 36. Find the ratio of students in the class and number of students in the first class if the second class has 90 students. Now here we need to find the ratio, so obviously using formula 2 is far better. Now A1 is given as 30, A2 as 40, and the average is given as 36, that is AW is 36. So directly applying our formula, we get N1 by N2 is equal to 40 minus 36 upon 36 minus 30, which is equal to 4 by 6, which is 2 by 3. Now doing the second part, if N2 is 90, N1 obviously will be 60. Let's do the next example. 4 kg of rice priced at rupees 10 per kg is mixed with 6 kg of another variety of rice to obtain a mixture of price rupees 12 per kg. Find the price of the second variety of rice. Now here 4 kg of rice means N1 is given as 4, priced at rupees 10 per kg means A1 is 10, mixed with another variety of 6 kg, which means N2 is 6, but we don't know A2. We obtain a mixture of price rupees 12 per kg, so it means that AW is 12. So applying our formula 2, we get 4 by 6 is equal to A2 minus 12 upon 12 minus 10, which implies that A2 is rupees 13.33 per kg. Now let's do the next question. 40 liters of a mixture of milk and water containing 20% water is mixed with 60 liters of a mixture containing 30% water. Find the percentage of water in the final mixture. Now, the trick here is to realize that this is actually a question of alligations. Otherwise, if you don't realize that, you will use the following conventional method. Water in mixture 1 is equal to 40 into 0.2, which is 8 liters. Water in mixture 2 is equal to 60 into 0.3, which is 18 liters. So total water in both the mixtures is equal to 8 plus 18, that is 26 liters. And the total mixture quantity is obviously 40 plus 60, that is 100 liters. So percentage of water is obviously 26 by 100 into 100, that is 26%. And how do we solve it using alligations? First, we need to identify N1, N2, A1 and A2. But how do we know that this is a question on alligations? What are the characteristics of an alligation question? In alligation question, we will always have two different groups, both of them having some characteristic property or quality and having some definite quantity. For example, in the previous example, we had two different groups, both groups of rice, but two different groups, right? Two different qualities of rice. So we have two groups having different qualities. And what was that quality? The quality was different prices. One group had a price of rupees 10 per kg and the other had a price of rupees 13.33 per kg. And both the groups had some quantity associated with it. The first group had 4 kgs of rice and the second group had 6 kgs of rice. So any alligation question will have two different groups. Both groups will have some definite characteristic property or quality and have a definite quantity. In this question, we again have two different groups. What are those groups? The groups are two different mixtures of milk and water. What is its characteristic property or the quality element? The quality element is that the first group contains 20% water and the second group contains 30% water. And what is the quantity? Well, it is given that the first group has 40 liters of that mixture, which is the quantity of the first group, and the second group has 60 liters of the mixture, which is the quantity of the second group. Therefore, we have N1 is equal to 40, A1 is 20, N2 is 60, A2 is 30, and we need to find AW. So AW is equal to 40 into 20 plus 60 into 30 divided by 40 plus 60, which is 26%, which is the same as above. Thus, the mixture contains 26% water. Now you may have noticed that when we solved the question using the conventional method, we were essentially doing the same thing. But by using the alligation formula, we have got the answer in one line. So let's move on to the next question. Two containers A and B have milk solution. The ratio of water to milk in container A is 3:1 and the ratio of water to milk in container B is 4:1. How many liters of container B solution has to be added to 20 liters of container A solution such that in the resulting solution, the ratio of milk to water is equal to 6/19. Again, the important thing to realize here is that this is a question on alligations. But first, let's use the conventional method to solve this question. Let the quantity of solution B to be added is equal to X. Then water added will be equal to 4/5x and milk added will be equal to 1/5x. As the ratio of water to milk in container B is 4:1. Now 20 liters of solution A is added. This means that water added is equal to 3/4 into 20, which is 15 liters, and milk added is equal to 20 minus 15, which is 5 liters. So total milk added is equal to 1/5x plus 5, and total water added is equal to 4/5x plus 15. So the ratio of milk to water is 1/5x plus 5 upon 4/5x plus 15, which is equal to x plus 25 upon 4x plus 75. Now this ratio has to be 6/19. So 19x plus 475 is equal to 24x plus 450, which implies that 5x is 25 or x is 5 liters. So 5 liters of solution B needs to be added. But this process is very lengthy. So let's try to use our concept of alligations. N1 and N2 here are obvious. N1 is given as 20 liters and we need to find N2. But what about the characteristic property or quality of the two mixtures? That is, what are the values of A1, A2 and AW? Well, we are given the ratio of water to milk. So let's take the percentage of water in the mixture as its property. Then A1 is equal to 3/4 into 100, which is 75%. A2 is 4/5 into 100, which is equal to 80%. And what about AW? AW is 19/25 into 100, which is 76%. Therefore, by applying our formula of alligations, 20/N2 is equal to 80 minus 76 upon 76 minus 75, which implies that N2 is equal to 5 liters. So as you can see, using the concept of alligations has made this question a very simple one. Now let's apply our concept of alligations to a question where I am sure that most of the students do not realize that alligation concept can be used. A shopkeeper incurs a loss of 10% on 25% of the goods. At what profit percentage should the remaining goods be sold so that the shopkeeper can make a net profit of 20%? Now at first glance, this looks to be a question of profit and loss. Actually, this is a question of profit and loss, but we can use our concept of alligations. But first, let's solve this question using the traditional method. Now let the price of the product be X. In fact, let's assume that the cost price of the product per unit is rupees 100 and let the number of goods be also equal to 100. Why am I assuming the values as 100? Because I want to simplify the calculations. I do not want to assume the values as x and y and make the question too complicated. Taking the value as 100 would not lead to any error, as there is no condition in the question which conflicts with this assumption. So the shopkeeper sells 25 goods at a loss of 10% or at rupees 90 per piece. Because if he incurs a loss of 10% on rupees 100, it means he sells the goods at rupees 90. So from the first 25 goods, he earns a total revenue of 25 into 90, that is rupees 2250. Now, he needs to sell the remaining 75 goods at a particular profit percentage so that his net profit percentage is 20%. Now there are 100 goods priced at rupees 100 per piece. So total CP or cost price of 100 goods is 100 into 100, which is rupees 10,000. He earns a net revenue of 20%, which means his total revenue is 10,000 into 1.2, which is equal to rupees 12,000. Now he has already earned rupees 2250 from the first 25 goods. So from the next 75 goods, he needs to earn rupees 12,000 minus 2250, which is equal to rupees 9750. This 9750 has to be earned from the remaining 75 goods. So what is the price at which he sells each of them? Well, it is obviously 9750 divided by 75, that is rupees 130 each. As the cost price was rupees 100 each, he sells them at a profit of 30% each. Okay, I made a blunder here. I wanted to show the beauty of the concept of alligations, but by assuming such nice and easy values, I have made this question very easy by using the conventional method as well. But now let's apply the concept of alligations. Now the first trick is to identify that this is a question on alligations. And the second trick is to identify which of the values above correspond to N1, N2, A1, A2 and AW. Now 25% goods means that it refers to a quantity. So N1 is 25. And what is the property of this quantity? The property is that it is being sold at a loss of 10%. So A1 is minus 10. Why minus? Because the negative sign indicates that the shopkeeper incurred a loss. We denote loss by minus sign and profit by plus sign. Similarly, N2 is 75 and we need to find A2 such that AW is 20. Why is AW 20? Because the total profit or the average profit is 20%. So applying our formula, we get 25 by 75 is equal to A2 minus 20 upon 20 minus 10, which implies that A2 is 30%. So the shopkeeper needs to sell the remaining goods at a profit of 30% to obtain an overall profit percentage of 20%. Very easy, right? Let's do one final example on this concept. Among all the passengers traveling from the Delhi airport, 35% are domestic passengers and the remaining are international passengers. In March, there was a rise in the number of domestic tourists by 30% and international tourists by 20%. What is the percentage increase in the net passengers? Again, let's first solve by using the conventional process. But we are again going to cheat here. We are going to assume that the total number of passengers is 100. So 35 passengers are domestic and 65 are international. In March, domestic tourists rise by 30%. Now 10% of 35 is 3.5. So 30% of 35 is 3.5 into 3, which is 10.5. So now there are 35 plus 10.5, that is 45.5 domestic passengers. Now what does 0.5 passenger mean? Does it mean that one passenger is a child and is counted as half? Well, obviously not. We get such a strange figure because we assumed the total number of passengers to be 100. But it does not make a difference. So let's proceed. International tourists rise by 20%. 10% of 65 is 6.5. So 20% is equal to 6.5 into 2, that is 13. So number of international tourists is equal to 65 plus 13, which is 78. Hence, the total number of passengers is equal to 75 plus 45.5, which is 123.5. As the initial total passengers were 100, there is a rise of 23.5%. So again, by taking the quantity as 100, we have made this question very easy. And what about the alligation process? Well, we just need to identify N1, N2, A1, A2 and AW. 35% of passengers are domestic, which means that 35% is being used to denote a quantity. So N1 is 35, N2 is obviously the remaining, that is 65. As there is a rise of 30%, so 30 is representing a quality. So A1 is 30, similarly A2 is 20, we need to find AW. AW is 35 into 30 plus 65 into 20 divided by 35 plus 65, which is 1050 plus 1300 divided by 100, which is 23.5%. Hence, there is a rise in total passengers of 23.5%. Now, this brings us to the end of this video. I would suggest that you solve all the quiz questions that we have given, and in the next video, we are going to study the last topic of this chapter, which is on mixtures.